Hello and welcome to my channel Rapid Vectors. In this tutorial I will show you how to create a shader and use this in a scene transition screen. When the player starts the game, you will see a loading screen, and then when the player moves between levels you will also see that loading screen. And if you like what you see in this tutorial, please hit like and subscribe to receive future updates of my other tutorials. So let's begin creating our loading screen. We'll go Scene, New Scene, and then choose Other Node and search for Canvas Layer. Click Create, and then rename this layer as Scene Transition Screen. Add a child node and search for Texture Rect. And then for the anchor point, let's choose the full rect here. And then in Texture, choose New Canvas Texture. Just open up the UI folder and create a new folder and call this Screen Transition, and then save your scene inside that folder. Just click Save. When we create the shader, I will be using two textures out of this noise pack. So visit the link in the description below the video and download the noise texture pack from itch.io. When you visit the download noise texture pack webpage, there are three variants of the textures in different sizes. In this tutorial I am using the variant 128 by 128, so download this option here. When you have downloaded the noise texture pack and unzip that, go into the 128 by 128 folder and we will download two textures which we will use for our shader. Go into the cracks folder first and we will take the cracks 02 image and then just drag that into the screen transition folder. So we'll use this one first, and then we'll go into the creators folder for the second image, and we want the creators 04 image, so we'll drag that also into the screen transition folder. Then in the texture rect inspector, just scroll down until you get to the material section, and then just click on empty, and we want a new shader material. In a previous tutorial I showed you how to create a visual shader, but for this shader we will choose the first option so that we will write this shader using code. Click Create, and then just double click the shader to open that. And let's just open this window so we can view our shader. So for this shader type, we are going to use Canvas Item. This type of shader will affect the 2D objects within our game. The second part is the fragment function, and we are going to make all of our calculations within this function. And the fragment function is a stage in the rendering pipeline, and this is where the individual pixels of the screen are going to be processed. And the fragment shader function is mainly responsible for computing the final color of each pixel on the screen. And it can take some inputs from the vertex shader, it can interpolate values across primitives, and what it will then do, it will perform those various calculations to determine the pixel's color. As you can see, I've added the vertex function, which is another stage in the shader pipeline. Now the vertex function can transform the position of vertices, and then it can pass that data such as colors or texture coordinates to other subsequent stages. Now for this shader, we won't use that vertex pipeline. However, I've just added it for now with a small explanation because you may see that in other shaders online. However, for this shader, we won't be using this method. And if you have never worked with shaders before, there is a resource online called thebookofshaders.com, and this is a resource that you may find helpful. Now let's begin creating our first parameter. So we want a uniform sampler 2D and give that the parameter name noise texture. We want a second parameter which is uniform sampler 2D and call that dissolve noise texture. Then click on texture rect, and as you can see these two variables here have created us two parameters here. So for the noise texture, choose cracks 02 and place that into there, and then for the second parameter which is the dissolve noise texture, drag in creators 04. I would just expand the side panel so that you can see a little clearly these parameters here. And in the fragment function, let's start sampling the noise texture. So the first thing I want to do is to say float noise value and then use the function texture, pass in the noise texture and use the UV and the R channel. Then I want to sample the dissolve texture, so we'll use dissolve value, then the texture function, use UV and then the R channel. I'm going to create another parameter which is a uniform vector. I'll call this color 1, which is of type source color, and I'm going to set this color black. So we now have another shader parameter, color 1. Now that we have a color parameter, what we can do is affect the output of the shader. So we'll assign that color to the pixel of the shader, and that will now change every pixel to black. But what we would like to do is to use the noise value and then the dissolve value too, and assign that to color. So we'll do vec4 and then noise value. And as you can see, that is then bringing the texture into the shader. And what we can do is also use the dissolve value. So I'm going to just subtract that from the noise value, and that is blending the two textures together. The next step is to modify this UV value. The image at the moment is just using one single image, but it is possible to tile this. So let's create another variable, which is a uniform float, and we'll call this tiling factor. I'll use a hint range function and pass in 1 and 10 and set this to a default value of 1. This will then allow us to modify the tiling factor property here. Then above the noise value, let's create vector2 UV, then use the UV and multiply that by tiling factor. Then copy the new UV variable, and just note this is lowercase because we're creating a new vector2 parameter here, and then just replace that in the texture functions. And then let's move the tiling factor so we can see that the shader is starting to tile, but we've got some bars here and bars below the shader as well. So to fix those bars, we need to say UV equals and then use the fract function and then pass UV in as a parameter. And that now fixes the tiling issue. Now we will manipulate the UV coordinates so that we can move this noise texture down. Let's create another parameter for this. We'll say uniform float and call the parameter move speed. Let's use a hint range with 0.1 to 5.0 and a default value of 0.1. In the shader parameters, this will then be set here, and we can then adjust that value. Now underneath the UV multiplied by tiling factor, we'll grab the UV and then on the y-axis, we'll say plus equals, then we'll use time to grab the time, and then we'll multiply that by the move speed variable which we've created. As you can see, the noise texture has started to move but is moving in the upward motion. So we can change that by just negating the move speed so that we get the texture to move the opposite way. So I would like to create another effect. As there are two noise textures, I'd like the dissolve texture to move in and out over time, so it subtracts over a variation of some speed. So let's create another variable, which is another uniform float. Call this parameter subtraction speed and use a hint range of 0.1 5.0 and a default value of 1.0, and that will add the parameter to the inspector. Then after the dissolve value, let's calculate the subtraction factor. So we'll use float subtraction factor equals, use the sin function, and then we'll use time again and we'll multiply that by the subtraction speed. Then we need to make a modification to our final value. So we'll change the vec4 to be a float and then just remove vec4 so that it is just noise value minus the dissolve value, but then open the parentheses and then multiply the dissolve value by the subtraction factor. And then for a final value, just put that in a vec4 for now. And as you can see, the dissolve texture is now dissolving in and out of the texture with the other noise texture. And this is because over time we are using the subtraction speed to create our subtraction factor and then deducting that from our noise value. The next step is to interpolate the colours into the pixels, and that will improve the effect. So for colour 1, I'm just going to pick a random colour for now. I'll do the same for colour 2. And then under final value, write vec4, final colour equals, and then use the mix function, passing colour 1, then colour 2, and then final value. And then replace vec4 final value with colour. And as you can see, we're now blending the colours into the pixels. So I'm now going to choose 2 colours that are more suitable for the game. I'm just going to use the eyedropper and pick those. I'm going to increase my tiling factor. I'll choose 2.5. I'm going to increase the subtraction speed, so it just speeds it up a little bit more. I'm going to do 2.5 for that as well. I'm going to increase the move speed, although that's a little too fast, so I'm going to reset that back. So the subtraction speed is probably a little too fast, so I'll go and put that back as well. So I'm happy with this result. So once you've created this shader, you can change the colours, change the tiling factor and speed so that it is more suitable for your game. Before we move on to improving the scene transition screen, inside the fragment function of the shader, I have now added comments to each of the lines of code to explain the steps that we have taken to create this shader. So it might be worth pausing your video so that you can read these in a little more detail. And if you really like what you've just seen, please remember to hit like or subscribe to my channel so that you get future updates on other shaders and other tutorials. Now in scene transition screen, click that and then choose add child node and search for margin container. In the anchor settings, choose full rect. Then on margin container add child node again and search for a label. Create that. And then inside the text field of label, type loading. And then for the sizing settings, under horizontal alignment, choose shrink end. And under vertical alignment, also choose shrink end. Then click on margin container again. And then go into the UI folder. And under the theme folder, we created a theme in a previous tutorial. Then on margin container, just scroll back down and let's just assign that theme here. Then in the theme folder, double click the game theme file and we need to style the label. So we can just click this eyedropper here and then just click label and then click this option and we'll change the font file and do quick load and we'll choose the gravity regular font. And as you can see, that's now updated that for us. And I'll just zoom in on the label, I'll click on label and then just scroll down and on the theme override, I'll just click font shadow and I'll just choose a different colour. And the reason why I've done it in the theme override is so that this doesn't affect every single label. If I change the font shadow in the actual theme itself, then this will be applied to every single label. Now we can test the scene and just maximize the screen. So that's looking good. We've got the loading text here. And then let's head over to our scripts folder and open up the scene manager script. And let's use this scene transition screen just before we move from one scene to the next scene. So we'll create another variable and call this scene transition screen and then preload the scene transition screen from our UI folder. And under scene path, we'll create a scene transition screen instance and then use scene transition screen which we've preloaded and then instantiate that. Then say get tree dot get root and then add child, and then inside of the add child function just pass in the scene transition screen instance. Then let's increase the timeout to be 5 seconds. Then after the scene has transitioned, we want to then say scene transition screen instance and then Q3. And now we are ready to test the game. Once the game is loaded, let's click play and we get the 5-second wait while the screen is transitioning. Then we are in our first level. I collect the access key and then we are ready to transition through the door. And this is now loading ready for our next level. Now that brings us to the end of this tutorial on how to use a shader and create a scene transition screen and then show this to the player when they are moving between levels. If you like what you've seen in this tutorial, please remember to hit like and subscribe and receive future updates of more tutorials. Thank you for watching.